I'm going to talk today about Little Big Planet. I might mention a couple other things, but mostly it's just Little Big Planet. Before we do that, though, I should probably introduce myself. There's really only about 2 things you need to know. I wrote the TextMate book for the pragmatic programmers, and my name's Jim Wyrick. So just ask your friends to point me out in the hallway, come up to me, talk to me about TextMate. I love that. So I'm just kidding. I'm James Edward Gray II. I did write a few pragmatic books, including the TextMate one. I've done quite a bit with Ruby's standard library, documentations, and patches and such. I wrote a couple of libraries, Faster CSV, which is now the standard CSV library in Ruby 1.9, as well as Highline with Greg Brown. And I ran the Ruby quiz and created it and ran it for 3 years. Also, you have to be really careful what you put on slides like this, just so you know. I always put that on there because the Ruby quiz was the first thing I did, and I figured that was what people knew me for. And then a guy comes up to me in Austin last year and says, "You probably don't remember me, but you utterly destroyed one of my Ruby quiz submissions a few years ago." So, not good. Okay, so I promised to talk about Little Big Planet. Let's get to that. For those of you who don't know, this is Media Molecule's hit platformer for the PlayStation 3. It's called Little Big Planet. And it's your standard platforming game, plenty of running and jumping and destroying little bad guys and things like that. What makes it really interesting, though, is right here you can see me playing through one of the Japanese levels that comes with the game. But the interesting part is that the levels that come with the game are more like an introduction to the real exercise, which is you can make your own levels. And as you go through the game-given levels, you collect all the items that are used in the game itself. So you'd collect like these rotating platforms and the stone pillars that they're attached to, and even the little bad guy, I think they're supposed to be pieces of sushi or something. These little sushi bad guys and stuff, and then you put them in your own levels. And people make levels for everything. You know, Mario, Zelda, Metal Gear Solid, Pirates of the Caribbean, you name it, there's a level for it. And it makes this vibrant community of levels that people play and mess around with. So I said you can make anything, and I mean it. You get all kinds of materials in various shapes, and then you have tools to edit those into what you want them to be. And then you get like brains and wheels and legs for locomotion and eyes for tracking and stuff, so you can make like these little monsters. Or you get pistons and these twisting bolt things that you can use to make complex machinery. And the cool thing about this is all these levels, everybody publishes these levels online, and then you can go hunt through them and figure out how they did all this stuff, right? Or at least that's what I do. I go play everybody's level, and I'm like, wow, that's so cool. How did they do that? And I try to figure out, you know, which pieces they hooked up where and how they got it to do that. So it's confession time. I read everybody's code. I just love that. I read tons and tons of code. And I think we should all be doing that, actually. In fact, you should be reading a lot of code, I think. These are totally my opinion, based on the Dreyfus model of skill acquisition, but I think there's important things to notice here. By the way, if you're not familiar with the model, this is all the 5 stages of learning you go through. So everybody in this room is somewhere on the scale with Ruby, and each stage defines what you know and what you need at that stage to progress to the next stage. If you're curious about that, Pragmatic Thinking and Learning is a really great book on it. But the important thing here is that I think people should read a lot of code. By the expert level, I think you should be reading more than you're writing. But even, you know, we can debate these numbers in the hallway if you want, but even if you cut my numbers in half, ask yourself if you're reading that much code. I don't think a lot of people are. So why is code reading so important? There's a lot of reasons. I think it's David Black who always likes to say that you should read Ruby's standard library to learn how Rubyists write Ruby. right? It's 90-some libraries that ship with Ruby that were written by Rubyists, so you can figure out how they do things, right? Also, you got to practice breaking down code because it's something you're always going to have to do, whether you're pair programming or finding a bug in somebody's library that you've used, you're always going to be breaking down code. And understanding how things work, tell you what their limitations are, and then you can learn where you can and can't rely on things. And a lot of people think you have to look at good code. That's not necessarily true. Bad code is great to see too. Going back to the standard library example, there's definitely both in the standard library. I think the path name library is a really great example of good interface design. I think the CGI library is the opposite, right? So that's why we have rack now, right? And then, just in our industry, we always have to have so many ideas, right? You have to think of new things all the time. I always wake up and tell my wife, I have to be smart again today. It's like my joke. But we do. We always have to have ideas. So you seeing other people's ideas and then thinking of how you can incorporate those, it helps. Okay, so let's get back to Little Big Planet. Enough of that boring stuff. One of the reasons Little Big Planet is so successful is how well everything's tied together. This is the main character, Sackboy, and you can see he's this funny little puppet with zippers and stuff that you can pose and control the expressions of and everything. It makes him fit in really well with this hodgepodge world of levels that people create. And there's also libraries, I think, that fit in really well into their world, like RESTCLIENT. And I want to show you a little bit of that. So RESTCLIENT is this library you can use to interact with web services. And it's kind of like Active Resource, but less, you don't have to build classes to use it. You just use methods on it. It's well-written code, and by that I don't mean that it doesn't have bugs. I forked it and fixed a bug on GitHub just a few weeks ago. What I mean is that it's written well enough that I can find the bugs to fix them. And it has a few neat features that I think are worth looking at. So if you've never seen RESTCLIENT, this is the basic usage of it. I'm actually using the wordy interface version of it here, so it takes 2 lines to read my tweets here from Twitter. The first one, we give it a resource that we want to interact with, a name and a password. And then in the second one, we pick an action of that resource, the friends timeline, and call the get method on it, right? Or you could call post or put, delete stuff. So here is the post if you wanted to post to Twitter. Notice that only this one line changes, which is why I use the wordier interface, because you can reuse more. So that's what RESTCLIENT looks like in practice. But here's some things I want you to see inside of it. Let's pop up the hood a little bit. First of all, I know this is a lot of code, and I'm sure you can't read all of it. That's fine. That's not the point. I hope you can tell, even from the structure, that it's pretty clean code. Obviously, the lines aren't long enough to have, just ridiculous chaining going on. It makes good use of white space and things like that. On the left, this is the interaction with NetHTTP. On the right top, we have the request result processing, so the response processing, sorry. And then on the bottom right, we have decompression. So these are probably the 3 ugliest pieces of RESTCLIENT. So it's very, very clean code. If you've ever heard the expression that everything in the method should be written to the same level of abstraction, you can really see that in RESTCLIENT. So it's kind of nice to read through the code and see what good-looking code looks like. I write a lot of NetHTTP interaction code, and it never comes out quite this good-looking, so not sure why that is. RESTCLIENT also comes with this full-featured shell that I want you to see. First of all, you can use it as like a curl replacement, where you just give the action that you want to do, the URL, name, and password, and it in this case it returns your tweets. And we can see that Jeremy also has a Twitter client that he needs to be telling us about this weekend too. So, and a book. He's really popular. Also, you can use it as a full IRB shell. So I can start it up here and give the URL and the name and the password. And then I can interact with it in IRB using these post and get methods to actually play around with a web service interactively. Okay, and notice that the interface changed slightly. I used to have the URL on the left side of post and get, and then any other arguments following that. These are just helper methods that the shell defines when it loads up, just to make the interface that much easier to play with. But the shell goes one farther. It'll log for you, and it'll do it in pure Ruby. So let me show you what this looks like. If we fire it up one more time, but we add an environment variable telling it where we want a log file to be put, it will create a log file for us as we play around, which actually turns out to be executable code, right? Because it's in Ruby. So in this case, I couldn't actually run it because it doesn't store sensitive information like a username and password. But and you notice that it's using a different way of calling into RESTCLIENT than I have been showing on these slides. But still, you can play around with like a public API and an IRB-like shell and have RESTCLIENT sitting there writing your program for you, which then you can edit to taste, right? That's kind of a neat trick we don't use often enough. I'm not going to show the shell, but you can look it up. It's very straightforward stuff. And we're seeing. Okay, so let's get back to the fun stuff. When I first came to Little Big Planet, I wanted to make Towers of Hanoi. This was my first attempt, and you can see it's mostly busted junk. I was trying to model the little wooden puzzle that I had, and these things up top just made that too difficult. So I kind of redesigned and rethought it and tried to fit something more in the Little Big Planet world. This got pretty close, but that door you see opening and closing gave me all kinds of fits with objects passing by it. This is the final version of Towers of Hanoi that I actually published to the Little Big Planet servers. And you can see that it's been redesigned. It's still the same Towers of Hanoi game. You still have to move the pieces in order and such. But both the puzzle has been redesigned, and then the interface has been redesigned in the way you interact with it to fit more in the style of Little Big Planet, and also to fit with the pieces that I had to work with to build this contraption. And you see that a lot in libraries, right? There's libraries that are very Ruby-ish, and then libraries that definitely aren't, right? And seeing those is good examples of how to write more Ruby-ish code, which I think is another reason that it's so important to look through libraries and see what people are doing. I wrote a library called Faster CSV quite some time ago that I think has some important points of designing to the problem in it. Actually, I've never talked about it in public until now, because I assume you guys find CSV as boring as I do. So I never talked about it, but I've been technically reviewing Greg Brown's upcoming Ruby Best Practices book. And most of these examples are pulled right out of there, and he's showing all this cool stuff with CSV, and I'm like, hey, I wrote that, I can talk about that. So anyways, one thing that I think is worth looking at in Faster CSV is that you need some tricky data structures. We want to access columns in order because sometimes the order is significant, but we prefer to work with them by name so that if columns are added or taken away, it doesn't break our code. But the columns repeat, so you need like this interesting data structure to handle all of these scenarios. Also, now that it's a standard library, it's been redesigned with multilingualization in mind. So I want to show you how I'd handle that in CSV. So let's start with the funny data structure, okay? Here's a simple example which shows us two things. First of all, we can see from the console sales figures that you need to be paying a lot more attention in the Wii talk than you do in this PlayStation 3 talk. And second, this is how you can access various bits of data in Faster CSV. You can see there's index access by name with a qualifier that it has to be at least at this index or later. And then we can use that to reference another index, which means we're doing all of our accessing by name. So we want the % column that's related to the units sold in 2008 column. And that way our data doesn't have to be reliant on the indexing, the location of things. I'm not going to show this code, but it's a simple associative array. And you can look it up in the source if you want to see what it looks like. So I think the new CSV library was the first big use of the multilingualization code. And I'm pretty sure of that because I think I found all the bugs when I wrote it. So, and they fixed them all for me, so you guys are all set now. But if you want to know how I did it, we tend to throw big data dumps at CSV, right? Because we get them out of a database or Excel or whatever. So if you had to transcode every time you read a line, you'd pay a pretty big penalty. And we want CSV to be pretty fast. So instead, I transcode the parser to your data and then parse. Okay, so then you only pay a one-time cost. So when you get data, I figure out what encoding your data is in based on whether it's an IO or a string. Then I define these simple helper methods for encoding data, simple strings and regular expressions in the encoding of your data. And then everywhere inside the parser that I use a string or a regex, I just call these helper methods to make sure that my simple string or regular expression is in your data's format. And that way the entire parser is actually in the format of your data, and it just parses your data in your data's format. It's a pretty simple trick. It gets a little annoying that you can't use, just straight string literals and stuff, and you have to be kind of diligent about that. But since all I need is commas and quotes and line endings, you can count on those in pretty much any encoding, so you can get away with a trick like this. There's other things you might like to see in faster CSV. The Ruby 1.9 version still uses one scary regular expression that I took out of mastering regular expressions and modified. That works great in Ruby 1.9, where we have RESTCLIENT, the really great regex engine that solves lots of great problems. In Ruby 1.8's system, it had plenty of problems because the 1.8 regex engine is pretty weak. So Timothy Elliott recently submitted a patch that converts it to use non-regex-based parser, and you can compare the two if you find that interesting. There's also another data structure called the table that lets you work with columns and or rows, and you can see that in faster CSV. So I mentioned that everybody publishes these LittleBIGPlanet levels, and I go looking at all of them. Here's one I found early on where they actually created a calculator in LittleBIGPlanet. So you see 10 plus 2 equals 12, right? But the cool thing is they give you this jetpack to go see all the machinery of how they did this. And this was the first way I learned how to do a complex machinery in LittleBIGPlanet. I also learned that this guy obviously has way too much time on his hands. But there's lots of Ruby libraries I've learned a lot from too, like BJ, Slave, and Terminator, which are those the 3 best named Ruby libraries ever, or what? So why are these important? Well, currently in my day job, I have to build really complicated multiprocessing Unix software, which means understanding things like threads and forks, pipes and signals, and all of that. And these libraries taught me how to do this, and they're written by somebody who has a lot of experience in the field. Ira T. Howard, he used to work for National Oceanic and Atmospheric Administration, and he did all kinds of clustering there that just had to have ridiculous uptimes. So it's really reliable software. So I'm going to show you an example of how Terminator works, because it's pretty cool. And I'll leave it for you to look through the other two if you have the interest. But Terminator is pretty easy to follow. For those of you who don't know, it's a replacement for Ruby's timeout library that comes in the standard library. Timeout has some problems on Windows and with system calls and stuff like that. Here's another way to do it that doesn't have any of those problems. And while this looks like a lot of code, it's not. This is just some option parsing up top, reading and resetting a signal handler before and after a block call. And all the magic happens right here in this call to plot to kill, which is you give it a PID, some seconds, and the signal you want sent, right? Ira comes up with great names for things, doesn't he? And then this is the plot to kill method. Again, more option parsing. And you can see this process. We write to it the PID, the seconds, and the signal. This is process right here. FATTR is an extension Ira uses, which just lets you define an attribute with a block default. So you can think of this as a method call. And then process does a piped open to another Ruby process, which you can see there's this Ruby method call, which gives us the path to the current Ruby interpreter. And then that program.inspect is the last piece of magic. And here's the program. It writes all this code, which is very simple. Look, it reads from standard in the 3 things that were passed, converts them to Ruby objects, sleeps for the required number of seconds, and sends the requested signal to the requested process. Very straightforward. Dumps all that to a temp file and returns the path to the temp file, and that's what you saw in the inspect there. So it writes out all this code, a little Ruby program on the fly, returns the path, and boom, you got a little time bomb out there, a process that'll fire a certain signal at you in a given amount of time. The other two libraries, BJ is a background priority queue for Rails. I learned great things from it, like how to notice changes from the outside world. It'll queue a job and then signal itself so that it notices the job immediately and acts on it. Managing and monitoring external jobs as it runs the external processes, and it keeps track of them and stuff, and it's neat to see how that's done. Slave is dirt simple ICP, where you give an object and it forks it off in another process, and then you can communicate with it over DRB. So very easy to do. And I learned how to set up heartbeat processes, which monitor each other and figure out when they go away and stuff like that. And also how to do DRB over Unix sockets, if you've never seen that done. So I'm telling you to go read all this code and check things out. Like anything, there's plenty of inherent dangers in code reading. Lots of things that can go wrong. Even more so with Ruby, right? Because Ruby is so dynamic and things. So it helps to kind of have a plan or certain things you should watch out for so that you don't get frustrated as you're reading code. So these are some of the tips and tricks that I use when I'm looking at code. Hopefully they'll help you. First of all, if you're like me, you have that instant reaction when you open someone else's code. Oh, I didn't write this, so it's crap. And I usually take out like 15 lines and then try to run it. And of course, it just falls down and dies because the author knew so much more than I did about it, right? So then I realized why all that's important, and I put it back. Also, if you've never done a lot of this, don't start with Rails. I really like Rails. I've learned a lot of great stuff from it. I personally learned a lot of great dynamic coding techniques from the router, which is kind of out of fashion now and I think slated to be replaced, but still cool to read. But it's really complex and it's hard to follow through some things, so it's not a great place to start. Also, have a goal. At an OKRB talk, when a guy was showing off Sinatra, he said, and you can just do Ruby and then the name of your script and it launches Sinatra. I have no idea how it does that. So I cracked open the source code and went looking so I could show him how it does that. And I found plenty of great things along the way, but it's that goal that keeps you focused and gets you through it. So have a goal. When you want to get the code, there's two great ways to do it. First of all, if you're not familiar with this command, gem unpack and a gem name will spit the source code of a gem that's installed on your system out in the current directory. So you can just pop the gem source code out and peek inside. Or you can grab it from version control, right? Anonymous version control. However you get it, open it in your standard environment, your normal editor, like you were going to edit it. Because that's where you know all your shortcuts for getting around to different files and stuff, and so you'll be most comfortable looking around. When you're going to find things, try conventions. Executables are probably in the bin directory, like that RESTCLIENT shell I showed earlier. Usually, my module, my class, resolves to a directory structure that makes sense. Follow superclasses up, looking for methods you don't know where are. Remember to take into account mixed-in modules. But remember, Ruby is also very dynamic, and these rules don't necessarily have to apply, though they usually do. And hunt for something like core extensions. A lot of Ruby projects make a little section of core extensions, so if you can't find some method, it's probably hiding in there. And then when it comes to understanding the code, I like to read the tests because that's how the author meant for you to use the code. Check for examples, and load and play with certain classes by themselves. You can do that using IRB, the require switch, and then the class you want to load, and then you can just play around with it. And remember to use Ruby's reflection methods, right? Because Ruby can tell you what things can do. So you can use those to find out things. That's all the tips I have. That's all I have to say. I can take a couple of questions while the next speaker sets up. Any questions? Going once. Twice. No questions. All right. See ya.